Hello everyone, I am going to solve a system that has three variables, three unknowns, and there's three equations. And these are linear equations, and they say that because here I have x, y, and z, and they're all just raised to the first power. There's not x times y or y times z. So these are the forms of linear equations, and we're going to solve for x, y, and z. So it's sort of assumed for this video that that we already know how to solve if I had two equations and two unknowns. Like if I had this, just if I had two equations, two unknowns, we're supposed to be able to do that. So now we're going to do three equations and three unknowns. Okay, so what we do is typically is we pair the equations two at a time. So the thing is that I'm going to do an elimination method, and what we can do is sort of look at these and just sort of think, well, out of convenience, if I add this second and the third together, the x's will cancel out. See, I have negative x and positive x. So if I add those together, the x's will cancel out. So that's sort of the reason I'm starting with 1 and 2. But, sorry, not 1 and 2, but 2 and 3. So I'm going to start with 2 and 3. But you could start with 1 and 2, or you could start with 1 and 3. But you take 2 at a time. So I have x plus y plus 2z equals 2. X minus 3y plus z equals negative 1. So we could have done like 1 and 3. You just take 2 of them, and you eliminate one of the variables. But I'm picking those two because if I add these together, it immediately the x's cancel out. So negative x plus x makes 0. And then I add y plus negative 3y, and I get negative 2y. And then 2z plus z is 3z. And then 2 plus negative 1 is 1. So there I get, I guess I'm going to highlight this, even though that's, not the answer, but sort of getting closer to an answer. It's like one piece, okay, of that. And now what I'm going to do is I'm going to use the first equation, and I'm going to try to use the first equation with any of these other two, and I'm going to eliminate x again. So I already eliminated x. I want to eliminate x again. So I'm just going to take the first and the second and eliminate x. But the thing is that if we look at this, we see that x's don't eliminate quite as easily. If I just add these two equations, if I add these, 3x plus negative x does not make 0. So it doesn't quite work as simple as that. And so what I do as part of an elimination method is I look at the coefficients of x. If I'm eliminating x, and here I have 3 and negative 1. And I like that they're opposite signs. So one's opposite, and one's positive, one's negative. But I look for a least common multiple of 3 and 1, which is just 3. And then I use multiplication, and I'm going to multiply this second equation by 3. It's like finding a common denominator, least common denominator. It's really the same idea, except in this case, what we want them to be is one positive and one negative. But otherwise, it's like finding the least common denominator of in a fraction. So I'm just going to rewrite that, and then I see that when I add these together, now the 3x's cancel out. So again, it's like you find the least common multiple of 3 and 1, and that's 3, and you multiply so you get so that they're common there. Okay, so 3x and negative 3x, those cancel out, and we get 5y plus 10z equals 7. All right, now again, I wanted to cancel out x and not another variable because I already canceled out x the first time around. And so I have two equations that are highlighted in yellow that only have y and z. And so that takes a bigger problem that was, had three variables, and 3 unknowns, and it makes this into a smaller problem. So I'm making these little snail tracks. And so now I have something that's smaller in terms of the number of variables and number of equations. All right? And so now what I'm going to do is, so I just took those two, and now what I'm going to do is I'm going to use the elimination method again to eliminate either the y or the z. And by the way, if you feel more comfortable with substitution, you could solve for y in terms of z and then replace y by that expression of z. But I'm going to just do elimination. So I don't really see that, I guess I don't see that it's easier to eliminate y or z, although maybe it's a little easier to get rid of y because they're already opposite. One's positive, one's negative. But I have to look at 2 and 5 and find the least common multiple, which is just, it's just 10, right? So what I'm going to do is I'm going to take the top one and multiply by 5. That's going to give 10, and the bottom by 2, and that'll make 10. And so then I will rewrite these equations. Negative 10y plus 15z equals 5. 10y plus 20z equals 14, and then I add these. Now, it turns out that this is not going to come out to be an integer, and it's a fraction that's not even that easy to work with. So I copied this problem out of a book, and so anyway, but those canceled out. So I have z, so maybe I'll use a different highlight color, this green, that's a final answer for z. Now, so I found z, and now I'll go around, I'm going to go back up to this equation here, and I'm going to, that arrow means nothing except look over there. But let me snail track down again. I'm going to take this equation, one of the equations, and plug in z and then solve. I think I'll use the top one right there. I think it looks a little smaller there. And I'm going to use it before I multiply by 5. So I'll take negative 2y plus 3z equals 1. And I'm going to put in now the 29 over 35. So, yeah, it's not going to be, this is where I have to say that this is where it's not as much fun. But anyway, I'm already using this problem and not a different problem. Okay, so alrighty. By the way, it looks like I made a mistake. That's not good. It must drive everybody crazy. This is 19 right here. That's 19. 5 plus 14 is 19. All right, so this is 19 right here. My apologies. But I'm going to continue and not redo the video. So 3 times 19 is 57. And, all right, so then I'm going to have negative 2y equals 1 minus 57 over 35, and I'll find a common denominator of those. And subtract, and it looks like I have negative 22 over 35. 35 minus 57 is negative 22. And I don't like making mistakes, but I do make mistakes, and it often happens to do whether I'm tired or not, or I don't know, whatever. Sometimes I feel like it's not my very best thing of mental arithmetic, and I wish it were. I wish I were better at it, or just had better concentration maybe. But anyway, okay. So it's definitely frustrating making mistakes, but that's 11 over 35. Okay, so I reduce the fraction, And now I have z and y, and I need to find x. Under this part right here, it would be better maybe if I had said, put a heading, find y. That's what I was doing. I had z, and see, I had an equation of, it's probably way too small to see. So I had z, and I had this equation, two of them, that had both y and z, and they both could equally work to put in z is 19 over 35. So if I had z, then I can find y. So I found y. That's why I did that, because I had these equations that had z and y. I mean, that's why I did it first. And then next, I'm going to go back to take any of these equations, any one of those three, and solve for x by putting in y and z. And I think that now that I'm looking at this, doesn't it seem that the third one would be the most convenient to use that one? I think it would be. So I'll just use that one, and I'll put in the values for y and z. So I just, copy and paste it. So, okay, because I didn't want to forget it as I scroll down. So anyway, so here we have, I'm going to put in, so I have x minus 3. Well, I'm going to solve for x. So what I could do also before I plug in is which I think might be a good idea, is I'm going to write, I'm going to add 3y to that and put that on the other side, minus z minus 1. Okay, now I'm going to put in the values for z and y. So x equals 3, 11 over 35, minus 19 over 35, minus 1. So this 3 times 11 is 33 over 35, minus 19 over 35, minus 35 over 35. And I could have used any of those three equations. I thought the third one was the easiest. But, that's true. Okay, so 33 minus 19 is 14. Okay, and then so I have 14 over 35, minus 35 over 35. And so x is equal to, subtract there, and I get negative 21 over 35. All right, so it depends on the, I don't know whether you feel like you should use a little calculator to do that little fraction part. It turns out after all, a lot of times there's some math that's sort of advanced, but the problem I have is just the fractions and adding and subtracting. And I think that some people are better. I think actually young people probably, but maybe not. I don't know, maybe actually has nothing to do with that. It's in my head, I shouldn't have said that. Okay. So, but anyway, I think it's actually doing that stuff in my head is good for me, really good for me. I like doing that. And it's too much, too dark there. Okay. So that is the answer and how to do that problem. I will point out that I picked this problem and had these big fractions. I think a lot of problems in books will be a little easier. That they'll have integers as the solutions. So anyway, what was the hard part? The hard part was the fractions and multiplying those numbers out. Okay, so that's all for the video. And the thing is that, yeah, I don't know if I should zoom out at the very end so you can see all of it at once. But then it makes it really small on the screen. Or zoom in. See it. I don't know. We should have had more zoomed in the whole time. Okay, y'all take care. Bye.